Welcome, everyone. Welcome to this AWS Discovery Day webinar. Today's topic will be examining Cloud Practitioner Essentials, or also known as Introduction to the Cloud at AWS. Thank you, everyone, for attending. Let's get started. So, if we examine cloud computing and we compare that to before having cloud computing available to our on-premises type of deployment in a data center. Here are some things we are concerned with when we're dealing with a on-premises data center. We are concerned with one, capacity. How much capacity do we have? Enough capacity in the internet connection, our web servers, our databases, enough capacity to handle the maximum peaks of traffic that we may expect as traffic volumes vary. So we want to make sure that we build out enough capacity so we can handle the maximum volume of traffic when it occurs. But the issue there becomes that, we have all this extra capacity we've built, but most of the time we don't need it. And that's an issue. And we have a storage capacity too. We're about storage. Storage requirements are constantly growing, but they don't ever really get smaller. Organizations constantly collecting more and more data, so we have to expand our storage capacity. So all of that involves investment, capital investment, and purchasing new hardware and installing and maintaining that. But when we look at the cloud environment, some of the things we're going to be discussing here. There's these four points here. Cloud environments such as AWS, we have many different services. There's about 200 different services with AWS, and it allows us to have on-demand delivery. I can begin using services, deploy new capacity on demand as necessary. No large upfront investments for these services. I can provision computing resources and other things, databases, storage, etc. Provision them as necessary. And a pay as you go, pay only for what you use, a type of strategy. We're going to examine a few areas of some cloud computing components, services on AWS. We'll look at deploying servers on AWS. You need something like a Linux server, a Windows server. How do we do that? What services involved? Going to examine some different types of storage on AWS. Also, we will explore some database options with AWS and some other tools, services available for running applications or running some code on AWS. We're looking at cloud computing deployment models. One of the things we're going to see when we look at deploying resources in the cloud, whether it's servers or databases or storage or something else, that there are different ways of integrating this with your environment. And maybe you have an existing on-premises data center that your company has built and maintains, or maybe you're a startup type company. So we have one cloud deployment model, or we could call this is the all-in model. All of your resources are deployed in the cloud. You don't have a data center of your own. They're running your application servers, website, databases, etc. Everything is deployed in the cloud. An attractive option, especially for organizations like startups, so on. Then there's the hybrid deployment, hybrid cloud model, where you have an existing on-premises data center, and due to maybe capacity constraints, or you're running out of room, we're looking to expand, and we either have to build a new data center, lease another floor of the building to deploy our data center or something like that. Or we could expand and migrate some resources to the cloud. So we set up a hybrid model. We connect your on-premises data center to a cloud environment like AWS and use that cloud as an extension or to expand your capacity for your organization. Then there's on-premises type clouds, on-premises cloud deployment, or also sometimes called a private cloud, where some organizations will follow a type of model internally, similar to cloud providers that they provide publicly for customers, where they'll host some services that they offer to other teams or departments or divisions of their organization and allow those other departments or teams to take advantage of services that are actually being run and hosted by another division in your company. Some of the benefits of AWS and deploying things in the cloud, working with cloud services. Some of the benefits include agility. We talk about agility, especially if you were take it from the standpoint of developers that are writing code, developing applications. You have a lot of agility when it comes to deploying environments, deploying a new environment for some new application needs to be developed. We need compute resources and database and storage, and that sort of architecture can be deployed within a few minutes' time using some of the automation tools that are available with AWS. Gives you a lot of agility to create new environments, especially for developing new solutions and new products, new services for your customers. There's a elasticity, so the ability to adapt to changing traffic patterns, changing demand, where I can add more capacity as necessary to meet increased demand because we're having some special drive or something along those lines, like Amazon Prime Days, for example. And then the opposite, we want to remove that capacity when it's no longer necessary, so that I'm not paying for resources I've deployed, but I'm not actually using them. So we would try to adapt, just have the right amount of capacity as necessary for the current demand. Then we can realize cost savings and work deploying, maintaining resources in the cloud eliminates having to maintain things physically, physical hardware that's depreciating and needs to be replaced in a few years anyway. And also, once we get into the automation tools with AWS cloud environments, we can have rapid deployment, deploying entire networks and servers and databases and storage. It can be done within a few minutes' time, tens of minutes, using the automation tools that AWS makes available. So we look at agility, we're looking at the faster innovation, especially for developers in a typical enterprise type environment. We're starting up a new project, there's a new team starting up a new application. Well, we may have to put in requests, requisitions to get new hardware and wait for that to be purchased and shipped and then racked and stacked in the data center. And could take several weeks' time, could be 1 month to 3 months or longer before your hardware is available for developers to start working. Where with the cloud environment, again, using those automation tools, I could build a new environment within a few minutes. And developers can then start working on that project right away once those resources are available. But no wait for additional resources. We deploy additional capacity as necessary, and it really makes it more flexible for experimentation and innovation, trying new architectures and new services. That's just not as easy to do that in an on-premises type environment. And we also think about resources in a cloud environment, meaning resources, meaning things like your servers or your storage or your database, as really being disposable. If you no longer need it, well, then you can delete it from your AWS account. Of course, you'd want to back up your data or save your data, save your information as necessary. But if you're not using or no longer necessary to have some servers and databases and other types of resources, then we would remove them, delete them from the account. So you're not paying for something you're not using. There's elasticity. We'll see more of that coming up. There's some auto scaling features with AWS, so we can automatically scale capacity like compute capacity, and allows us to spread the workload, spread your traffic across multiple resources, whether it's multiple servers or multiple database instances, etc. So makes it easy to deploy fault tolerant, highly available type of resources and workloads. Cost savings. So we're trading capital expense for variable expense. So if you're looking at it from the point of view of working with a on-premises type of data center, it's a lot of capital expenditures, capex. Means we have to pay for the electrical bill and the heating and HVAC and the maintenance on that and the physical location, pay for all of the physical hardware that needs to be maintained and replaced and fixed when it's broken, etc. A lot of capital expenditures, building out enough capacity to meet your maximum peaks in traffic, but majority of the time you're not using all of that capacity. But you had to spend all the money so it's available when necessary. Trading that, working in a cloud environment for variable expenses or operational expenses, OpEx, you're paying for the resources you use, paying for what's currently and actually running on AWS. No large upfront investments, necessary. So the pay-as-you-go strategy, you get a monthly bill with AWS. There are some savings plans type of payment that are available for some services. You could receive a discount in turn for committing to a certain period of usage. Commit to 1 year of usage for some servers, for example, in exchange for receiving a discount. In that case, you do have the option of paying upfront, paying for a year upfront if you wish, but primarily it's pay as you go type of strategy. Rapid deployment and highly scalable platform. We'll look at some of the global infrastructure here. AWS currently has 34 different regions around the world. So we'll see that in a few minutes here. And new features, updating things being released as AWS continues developing their services they offer, and strong support for automation, deployment, things that refer to as infrastructure as code, for example. Means you literally have like sort of a form of code, like a template that we can use for deploying networking infrastructure, servers, and many other things, on AWS. So it's not manually being done by a human. Look at the global infrastructure. This is was constantly changing and being updated. So let's go look at the current state. Look at the current state of this on the AWS website. So the AWS website, just aws.amazon.com. And there, if you simply search for global infrastructure, you'll find the pages we're looking at here. And we're looking at some of the regions available. So let's look at North America first. North America, there's multiple regions available here. This regions are, of course, groupings of data centers that AWS has built. So you can deploy your resources in the cloud, deploy your workloads in the cloud in whatever region of the world you prefer. So we have regions, for example, you have the Oregon region here on the West Coast, the Northern California region. There is the Northern Virginia region. That was the very first region. So as see here, launched in 2006. And if we look at Europe, look at Europe here. There's some regions in Europe. A region in Spain, Ireland, and we got the London region, the UK, Paris region, etc. and so on. Middle East, Asia, Africa. There are, look at the overview. Here's the overview map. Currently 34 different regions around the world, with some additional regions in progress. There's a new one being built in Saudi Arabia, new one being built in Auckland and New Zealand, two in Australia. So as far as the global infrastructure is concerned, the region is the top level of the global infrastructure hierarchy. And this is, of course, all built and maintained by AWS. This is a private global infrastructure. Note, see in this particular map, you have these lines going across the ocean here, connecting all the regions together, going across continents, so in Africa and South America, etc. All these lines, this is the private AWS infrastructure, the private global network that AWS has built, connecting all of their regions together. AWS undertook the process of laying cable, fiber optic cable across the ocean, the Pacific Ocean, the Atlantic Ocean, and so on, for building their regions. So if you are transferring data, replicating data between different regions in AWS, it's happening on the AWS private global infrastructure. The traffic is not traversing the internet in that case. It's all in the private AWS infrastructure. So regions are the top level of the hierarchy. As you saw, there's currently 34 of those around the world, with more in the process of being built. Regions are then divided into availability zones. Availability zones contain the data centers. So availability zones, there are multiple, there's at least three of them in every region. And they're all interconnected with high-speed fiber optic connections. They're all fully redundant. They have their own dedicated fiber connections to the internet. They have their own power grids and power backups. And if we put that in the context of a region here, let's let's look at the Oregon region. So we have the region on the east coast of the United States, the Oregon region. And inside the Oregon region, there are four availability zones. And inside the availability zones, that's where you have clusters of data centers. And what that means from a sort of practical standpoint is that in the state of Oregon, spread around the state of Oregon in different areas are these four availability zones. They're all chosen to be be sort of fault tolerant from the standpoint of natural disasters, for example. And they're all interconnected with the high-speed fiber optics, so they can all communicate with each other. And this is our inside of a region. This is our level of fault tolerance or high availability. So when you're inside of a region, if I were deploying, a website and a database, for example, so deploy a web server and a database here. Best practice, best practice for deploying resources on AWS, you deploy to at least two availability zones inside of a region. That way you have some fault tolerance. If one of the availability zones goes offline, there's some issue, well, you still have your website and your database or whatever workload it might be, still running in a second availability zone. You could take that a step further and deploy your workload to multiple regions if you wanted to. One deployment on the West Coast of the United States in Oregon, the other on the East Coast, maybe in the Northern Virginia region. That, of course, is up to you. Then, in addition to the regions, the 34 regions, we also have 600 plus other points of presence, POPs as they're labeling them here. 600 plus additional POPs. This is what's known as the edge locations on AWS. Edge locations, the primary purpose for the edge locations, this is the AWS implementation of a content delivery network, a CDN, primarily used for things like caching content. I can cache the content from my applications, my website, etc. Cache it in hundreds of locations around the world, so it's closer to customers that are consuming my product and they get better performance, lower latency by utilizing these edge locations around the world. Now let's examine some services. We look at examples of some services. We will start with compute. So compute services, meaning, hey, I have some application, an application, or maybe it's a website, some sort of a web application, or email server, or database server, or something that I need to run in the cloud on AWS. So, what are my options for running some sort of application in the cloud? Well, we can utilize several different services. We'll talk about EC2, which includes some additional tools like the auto scaling. There's also the service known as Elastic Load Balancing, ELB, for distributing traffic across multiple resources. There are container-based services, and then there's a service called Lambda, which can be utilized for running code, running some application code on AWS. We'll start with EC2 first. So EC2 instances are really an implementation of a virtual machine. You might be familiar with virtual machines, maybe from your on-premises environment. Almost certainly in your organization's on-premises data centers, you are utilizing some form of virtual machine running on something like VMware or Microsoft's Hyper-V, something along those lines. And that's what EC2 instances are. It's just a virtual machine type deployment in AWS for when you need to run a server. You want a server, you need to run a Windows server that's running some type of application. You need to run a Linux server that you're going to use for your web server. You need to run a Mac OS type server. Those are your three options: Windows, Linux, Mac OS for the operating systems with your EC2 instances and the different, of course, versions and different Linux distributions available. So with EC2 instance, you can deploy server capacity when necessary. Takes if you just do it manually, just takes a few minutes. I'll do it here in a minute. You'll see how it works. Multiple pricing options available depending on what is how long is that server going to be running? Is it temporary or is it going to be a long-term type of server? And as far as those pricing options are concerned, this is an example. Some of the pricing options we have, uh, payment you could happen in the form of the on-demand instances. On-demand instances are these are ones that maybe these are short term or they need to temporarily, or they'll be running intermittently. They're not running all the time. You start it up and start it up again when you need it, and that can tends to be on the more expensive side for running your EC2 instances, and because they're not assumed to be running 24 hours a day. What if I'm deploying my website on AWS? I need a web server. It's going to be running 24/7, 365 days a year. Well, then you'd want something more like reserved instances. And there's another option called savings plans too. This would be like if I'm running my website, this needs to be running 24. I have these servers that are running 24 hours a day for extended periods of time running my website. Well, then you certainly don't want to do that with on-demand instances. It's going to cost you more money, much more expensive. With reserved or savings plans, and you commit to a period of usage, like 1 year period, for example, in exchange for a discount. You could get discount, and the discounts vary. It might be 30, 40, 50% less expensive compared to on demand, but you're paying for a certain period of usage, like a 1 year or a 3 year period. So then, then there are another option, what's called spot instances. These are in temporary EC2 instances. Spot instances, you are taking advantage of additional capacity that AWS has available, extra capacity that AWS may have available in a region, in a particular availability zone. Capacity AWS is built out, but they're not currently using it. So it's just sitting idle. And of course, they'd like to make some money off of it. So I'm going to sell it to you at a steeply discounted cost. But there's no guarantee spot capacity will be available if you want it. So that's the drawback. It might not be available if AWS needs it. If AWS, if it is available and you begin using it, but then later AWS needs that spot capacity, they'll take it away from you. So you have to work within the limitations where your application or a batch job or something like that, something you'd be able to start and stop at a moment's notice, stop at some point and just resume processing later when spot capacity becomes available again. EC2 also supports auto scaling. We can just launch, start up more EC2 instances as necessary to meet the current demand. There's many different options for that. There's a scheduled scaling. You could have extra capacity added at set times that you specify. There's dynamic and predictive scaling, where it dynamically adapts to the current demand. And we will scale out and scale in, and we are scaling horizontally. Horizontal scaling is just adding more servers. So if you're currently running for your base capacity, you have 3 servers running or something for your website. Demand is going up, traffic's increasing, your CPU utilization is going up. We can start up more servers. We have 3 running. Okay, let's start up 2 more servers for a total of 5, or start up, double it, start 3 more, double your capacity, etc. Like this. So what we're trying to avoid with auto scaling, we're trying to avoid this, which is what will tend to happen in an on-premises type of data center that you are maintaining. You have to build out your maximum capacity. What's the maximum expected traffic that we project, into the future? We have to build out all the capacity so that we have that available when necessary. But all this white area here, all this, my capacity is mostly unused most of the time. But they had all the capital expenditures of building and maintaining that, and the hardware's not being used much of the time. It's aging. It's needing to be replaced in a few years. Sometimes you need it. Sometimes you need all of it, like we have here. You need all your capacity, so you have to have the capacity available when necessary. But most of the time, it sits unused. So we try to just adapt when we're auto scaling and just have enough capacity to cover the current demand. We'll scale out when necessary, scale in, remove the additional servers when they're no longer necessary. And we do that in the context of an auto scaling group for EC2. You can set limits like you see here, some of the configuration. Auto scaling group, minimum number of servers I wish to run. The desired number when I start them, I want 2 running when I start up my auto scaling group. We could scale out to the maximum number you specify, or scale into, in this case, never less than 1. In this example, that would be my minimum. When we're scaling, so if I'm dynamically adding, removing servers in my auto scaling group, like we see here, how do I end up distributing traffic? I've got client traffic coming in from the internet. They've been using these 2 servers that are in my desired configuration. And then I scale out and suddenly there's 2 more servers available. I need the traffic to be distributed across these new servers that have been started. How do we do that? Well, that's the job of a load balancer, a load balancing type device. And there is a service on AWS we could utilize for that, elastic load balancing, automatically distribute traffic across your EC2 instances. Even the new ones, as the new ones are dynamically started to increase your capacity. The load balancers automatically becomes aware of them, and we can distribute traffic across all your EC2 instances, across multiple availability zones. This is best practice where you deploy your servers and your resources in multiple availability zones for some fault tolerance. So we would have, example, our elastic load balancer. That's what this is here. Your elastic load balancer, ELB. During a low demand period, we're just running our our base capacity of the two servers, and the load balancer is distributing traffic across those. When we have to scale out, we add more servers, and the load balancers automatically begins distributing traffic across the new servers that have been added. So let's look at that in the console. So let's go over to the AWS interface. That's what we're looking at here. So this is called the console. When you create an AWS account, you log into your account and you are presented with the AWS console, which is the web interface, just a web browser. And you log into your account, and you can then configure your resources and deploy things manually here. So let's look at EC2 instances. Go to the EC2 service here, and let's deploy a new instance. Now, we have instance types. We'll look at that briefly, where you get to select from among many different types of servers. So what's the performance characteristics that are necessary? So if you were to compare, for example, if you were purchasing or maybe building a computer for your own purposes or for your company, your own use, uh, you would have very different hardware depending on what type of usage will be performed. So if you're just looking at a basic office type computer that needs to run some, things like Word and Excel and PowerPoint or something and be able to reach the internet and handle email, you don't really need any special performance type of hardware for, say, that type of laptop. It's just going to function as an office, running some office applications for an employee. Uh, Compare that to, what about a high performance gaming type computer that needs to support, a high resolution 3D gaming applications and high speed internet connections. Well, then we have your very powerful and expensive video cards, graphics, your GPUs, graphic processing units, powerful CPUs, large amounts of memory. And that's what you're looking at here with the instance types. What sort of performance do you need? Do you need something that's very strong, has a lot of CPU processing power? Do you need an EC2 instance that has a large amounts of memory? Do you need very high performance storage, high performance storage subsystem in your EC2 instance, your server? Do you need high performance networking for very high speed networking connections? And you have, as you see here on the list, there's a long list of just different EC2 instance types, and they'll have varying amounts of memory and CPU power and strengths and weaknesses in different areas. So let's start up a new instance. Go create a new EC2 instance here. We're going to launch an instance, which is the create process. And we'll create a Linux server. We're going to choose a Linux distribution. Amazon has their own distribution of Linux. So Linux 2023 here. That will end up being installed. And here's the instance type. Now, some things are free on AWS. Some things are free on AWS. where you'll get a certain amount of usage per month, certain number of hours per month, where there's no charge, and the T2 Micro is one of those. Fairly small type of server, only one virtual CPU, 1 gigabyte of memory, but it's enough to run the EC2, run the Amazon Linux. Then there's some keys involved. This is for authentication if I'm going to connect to the server. We'll talk about some of the networking settings later. I'm going to select something called the VPC. We'll get to that later. And then select the subnet also. And some more settings for there's just a firewall type setup here. What size drive do I want? It's suggesting an 8 gigabyte volume, which is small by today's standards, but that's enough to run the Amazon Linux. We don't need anything extra. And that's enough just to make a very basic EC2 instance. We're to launch that. And it'll take a couple of minutes right before that becomes available. So if we go back to my instances list, refresh that, you'll see there's a new one that's starting up. So we'll give that a couple of minutes. Also here in the EC2 console, this is where we can find our auto scaling groups. We're going to set up auto scaling where we dynamically add extra capacity as necessary, scale out, scale in, and integrate that with a load balancer, or this is the ELB service here, to also in the EC2 console, where I could create a load balancer if necessary. And then the images, of course, the operating systems that we use to create the instances, those come from something called an Amazon Machine Image, an AMI. That's what you're looking at here. There are numerous AMIs available, literally thousands of them available from the AWS marketplace, some of which Amazon has created, and there's other vendors, other companies offering, their operating systems available. Here's a list of what's called the Quick Start AMIs. These are the operating system images from AWS. So you see there's Linux, Mac, different distributions of Linux here, and some Windows. There's a Windows servers coming up. We select your operating system as necessary to run your instance. Let's go back to my instance now. Should be available, and I can connect to this instance right through the interface here. Let's select that. Let's connect. And oh, I forgot to install. Here, let's go fix something here. It needs permissions. I forgot to assign some permissions to the EC2 instance. Needs permissions so that server is allowed to talk to other AWS services. All part of the security on AWS. You always need permissions to communicate and utilize other services. So I might have to restart that instance. It's not become available here. So we'll come back to that in a minute. Let's restart it. So I'm just going to reboot this server. And we'll come back to that in a couple of minutes. Now, EC2, well, that's the service that allows you to run a server of some sort in AWS in the cloud. Now, we also may have some applications that you are running in containers. So this is a popular way of running applications on premises. You might currently be doing it in your on-premises data centers, but running a containers means you package up your code into what we call a container, you package up your application, and then it's a very a portable type of way of deploying an application in different environments. And you don't have to run and manage an entire server, right? AWS could do some of this management for you. When we do that, when we run applications as containers, you may end up with hundreds or thousands of containers that you're running. So the challenge becomes, how do I manage all of that? You stop and start containers. You're going to be scaling. So we still have to think about scaling to meet capacity. So we start up extra containers as necessary, running your app. And you need some way of managing all of that. And we do that with an orchestration service. So as when it comes to orchestration services, there are two options on AWS for managing containers that you're running. One of those is ECS, the Elastic Container Service, which was a this is a it's like a native uh, orchestration service for the cloud. Means AWS built this specifically for the cloud, working with their AWS services, working with you're running your containers on EC2 instances, for example. And it was built and born in the cloud from the very beginning. They also refer to this as like an AWS opinionated service. Means it's the AWS way of managing and running containers in a cloud environment. But also there's another very popular open source orchestration service for running containers. Very popular in on-premises environment. It's called Kubernetes. Kubernetes, if you use that in your on-premises environment currently, and you wish to migrate some containers to the cloud, you have EKS, the Elastic Kubernetes service that AWS also offers. So you could use Kubernetes if you currently use that on premises. So you have people on staff that are very familiar with Kubernetes. Well, they can begin using that in the cloud environment at AWS. So in the end would be, well, you choose one, ECS or EKS, depending on your needs. ECS is the simpler, deeply integrated with other AWS services. EKS may give you more flexibility due to the open source nature and the open source community that's out there that supports Kubernetes. Other ways of running code, we have some services on AWS. There are some services on AWS in cloud and cloud environments that we refer to as, oh, this is a serverless service, meaning there are no servers for you to manage. Compare that to running an EC2 instance where you still have to manage that server, that EC2 instance, the same way you would manage it if you were running it in your on-premises data center. With the exception as well, you don't have to maintain the hardware part of that. But as far as the software, the operating system that's installed in the EC2 instance, the application you install and run there, your responsibility to keep that updated, to patch it when it has security vulnerabilities that are discovered, to secure it. You have to manage that the same way you would manage a server on premises. Serverless services, you don't have to do any of that. There are no servers for you to manage. You don't have to work with or manage, update, maintain EC2 instances. So there's a service called Lambda where you upload your code and AWS can run the code for you. Lambda code is usually triggered by some event, something happening with some other service in AWS perhaps, or it could be a schedule type setup where the Lambda code will run when necessary. Lambda function, they're called, will run when necessary, and you pay only for the compute time. You pay only for the compute time, the amount of CPU that's used. So compare that to if I have some code that runs total of 60 minutes in a 24-hour period. If I was running that on an EC2 instance, since the demand for the code is unpredictable, it could happen anytime. If I was running on an EC2 instance, I'd have to run an EC2 instance, 24 hours a day, just so that server is available to run my code when necessary. The code only runs 60 minutes a day total, but I still have to pay for a server that's running 24 hours a day. that's hosting that application code. Whereas if I hosted that in Lambda, I'd pay only for 60 minutes. I wouldn't have to pay for a server running 24 hours, only pay for the 60 minutes that the code actually spends running during any 24-hour period. Now, if we look at, so that's another option then for running, of course, applications. We can run them on EC2 instances. We need application or some sort of code. You could run them as containers using one of the orchestration services with AWS, or you could have Lambda functions if appropriate, if it fits the need, and not have to maintain or manage any types of servers. Let's go back to my EC2 instance here. Should be able to connect. Let's try that again. Now that it has the proper permissions, connect through the console. I'm just going to get a command line. So I'm just here at the Linux shell. Where we're in the bin directory there. It's just the shell of that Linux server here in this case. Content of our directory there. And then if the server is no longer necessary, you can, of course, back up your data from that. Back up your data, and then we could eliminate it. For example, terminating it. Delete the instance when it's no longer necessary. Okay, what about storage? Let's move on to these topic of storage here. And different types of storage. We're going to look at 3 different types of storage here. First, starting with what is known as object storage. So object storage with AWS. Got object storage. Sometimes this is called binary large object storage, maybe for its blob storage. But this is the service known as S3, the simple storage service, which allows for a very large amount of storage, virtually unlimited storage. The customer storing exabytes of data in S3 on AWS. And we refer to these as objects, and it's whatever it might be that you upload. You store and access any type of data in S3. Doesn't matter what it is. It could be text files, documents of some sort. It could be code. It could be images, video, backup files from your servers, etc. Anything. And you can upload them and store them in S3. S3 is a highly durable service. We look at this is 11 nines of durability. And that is referring to the odds or the chances of an object that you upload to S3, that object being unavailable or it's lost. AWS has lost it, the S3 service, lost that object. 11 nines of durability works out to if you have something on the effect, if you have a million objects, something like that in S3, you may lose one object every 10,000 years, something like that. And a wide range of cost-effective storage classes depending on the access pattern. How frequently are those objects going to be accessed? You have different options for how it's stored and what that ends up costing you. So with S3, we store files in buckets. There's a wide variety of use cases. I mean, this is again like just bulk storage for large amounts of data. It supports versioning, so you can track multiple versions of an object in S3. You can lock objects or put safeguards in place to prevent accidental deletions. We can put a hold on objects. So if you have legal requirements where I need to keep content for a certain number of years, something needs to be saved for 5 years, something we can lock them. So an object can't be deleted and can't be modified for the next 5 years. So that is storage. Look at S3. Look at the S3 service. And look at S3. Let's create a bucket. So I'm going right through the console once again. We will create an S3 bucket. And of course, there are permissions and there's the buckets. Now, these buckets can be publicly available if you wish, but the permissions are locked down, so the bucket is not publicly available by default. There's your versioning option. You want to support versions. There is encryption. Encryption is mandatory. So encryption is enabled by default here, the S3. Every object you upload is encrypted. And other advanced settings, that's enough. Just create a simple bucket here. And then let's store objects, upload something to that bucket. And I can simply do that. I can drag and drop it through the web interface here. So let's do an image, do a JPEG, drop that there, upload it. There it goes, uploaded. And let's see if I try to open that. S3 is a web-based service, means we interact with it over HTTPS, like you see here. Buckets get a domain name, as you see associated there. That's the name of the bucket I put in, and then the name of the JPEG, the picture. If I click on that, just get access denied. Because remember, the bucket's currently blocking all public access. So I have to go modify some permissions. For security, very important on AWS. S3 buckets are not public by default, but if I wanted to make it public, let's go back to the bucket, modify the permissions, and then I can disable that, disable the block public access. But that's not enough to allow access. I still have to grant permissions. So permissions are done with something called a policy, or specifically like a public or a bucket policy. So let's edit this, and I'll copy and paste the policy I have here. And then we need to put in the name. Everything on AWS gets an Amazon resource name, an ARN, which looks like this. I'd have to put that in the policy here so I can grant permissions to this, to the objects inside this bucket. So this policy is allowing public access, allowing anyone to access the content of this bucket. For example, the JPEG, the image that's there. Okay, add those permissions. Okay, now we should be able to open up that JPEG, go back to the objects list, and click on the URL here, and the image should load. There it is. So a picture I took when we were coming in to land the Seattle airport. 3 of the volcanoes in the Pacific Northwest. So Mount Rainier in the foreground, on the left, Mount Adams, and over on the right is Mount St. Helens. So S3 supports a wide variety of use cases. That is just bulk storage. You need large amounts of data that you want to migrate and store in the cloud, for example. And S3 is really our solution for that. Now, it's not the only type of storage. Because with the S3, what can you not do with S3? With S3, you cannot install an operating system and boot a server. You cannot boot an EC2 instance, from S3. It's not for that. So I need when I work with my EC2 instances, we need just like you would with physical servers, your laptop, actual servers you're working with in your on-premises data centers. You need hard drives. You need some sort of drive. Maybe it's a solid state drive. Maybe it's the old style magnetic hard drives. And on AWS, that service is EBS, Elastic Block Store. This is block storage, referring to the fact that the drive, because these are effectively just hard drives or solid state drives, which they are by default, solid state drives. You can you would need to format them with the file system. If you're installing Windows, we would format the EBS volumes with the NTFS file system. If you're running Linux, then you have a variety of Linux file systems you would format, just like you would format a hard drive in your own computers, your own servers. That's EBS volumes, they're called, that support booting up your EC2 instances. So you need at least one EBS volume with your EC2 instance so we can install the operating system on that volume. And then you can add additional volumes as necessary. You may add a second volume to run your database software, for example, host your database. So if you look at EBS volumes, you'd have an EC2 instance. Like if I was running a Windows instance, I'd have one EBS volume where I have Windows Server installed. That's formatted in the NTFS file system. And then I could add additional volumes as necessary. Say one for hosting, one boot volume to boot my operating system, a second volume for the database in that example. That's EBS, Elastic Block Store, equivalent to a hard drive that you would then attach to an EC2 instance for installing software, installing your applications. Then, another type of storage, file storage. This is referencing the need to have some sort of shared file storage, right? We need a file server effectively. Just like you have on premises, you have a Windows file server or a Linux file server. It's a central location. Users can store their documents. You can have hundreds or thousands of users, employees, other servers, other applications, and all accessing the same shared storage. And the service that implements that with AWS is EFS, Elastic File System, a fully managed by AWS shared file system. Specifically, this is NTFS and NFS rather, NFS version 4, the network file system, NFS v4, which is for Linux or Unix type, your operating system. So EFS would be your solution if you need a file server for Linux. You have, say, 200 EC2 instances running. We wish them to access a shared file store. EFS is the effective way of doing that. Effectively, you're running a file server, making it available to your other EC2 instances. And we can read and write documents there, access that shared storage. And other services like containers running on AWS, your containers could read and write from EFS file system. The shared file storage, it dynamically sizes, it adds capacity as necessary based on your storage needs, your storage demands. What about databases on AWS? Let's get into databases. Talk about some database services. We'll look at two different services here, RDS and DynamoDB. And then there are other services that AWS has available when it comes to migrating to the cloud. If you're looking at migrating a database, for example, database migration service, DMS, is available. Help you migrate an on-premises data center to the cloud, on-premises database to the cloud. And there are other migration services too for migrating servers and applications you might be running on premises. As far as database services are concerned, we will look at the first service here, RDS, Relational Database Service. This allows you to host databases, run databases of the type SQL type databases, SQL databases, where we use the structured query language to query the database. So these are very common types of databases that using RDS allows you to run a variety of database engines. I mean, different, what database type are we talking about? Is it an Oracle database? Is it Microsoft SQL Server? Or is it something else? It allows you to run that on AWS. And you have a number of database types available. We go look at, go to our console, Smite RDS. If I wish to deploy a database, I can do that here from the Relational Database Service console. Create a new database. Keep in mind, this could all be automated too. Everything I'm doing manually here, assuming that could all be automated. And then look at database engines. So we have 8 different database types that are available. So MySQL, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server, and IBM DB2. And then there's the offering called Aurora, which are highly optimized implementations of MySQL or PostgreSQL. So Aurora is a service AWS offers to increase the performance. You get 3 to 5 times the performance using Aurora versus using the standard implementations of something like MySQL. So you'd select, well, what sort of database do I wish to run? Other parameters, what version, if I was going to run a MySQL database, what version do I need? AWS supports a number of different versions. What about high availability? Do you want to store your database in multiple availability zones? So this is multi-AZ. What about credentials for your database? Other options, the size of the storage you need to allocate, etc. And then you could, of course, deploy your database. So for relational database service, RDS, we're deploying your SQL type databases or migrating them to the cloud. Now, there are many different types of databases. Most common ones, we talk about databases, most people thinking of that relational type database or the SQL type databases. But with relational databases, there are some limited performance scaling options with relational databases. If we need to increase the performance to extreme levels, there's difficulty in doing that with relational databases. Then there's some more things like the tightly defined schema of what type of data can be stored in the SQL database. There are times where, okay, I just don't need that. I don't need a relational database to store some basic information. I simply want to store something in a key value pair type of relationship where there's the key or the name, and then there's some value assigned to that. So that's all I need. And I need extreme levels of performance. I need to be able to handle like a global database that runs in multiple regions around the world and handles millions, tens of millions, or trillions of queries per day. So these are known as no SQL databases, no SQL databases, because in part because they're not a relational database. It's not based on the SQL type of architecture like your relational databases are. And primary solution with AWS is DynamoDB for that type of database. This is a serverless. Remember, we talked about Lambda being a serverless service, meaning there's no servers for you to manage, no EC2 instances that you need managed with Lambda. Well, this is another example of a serverless service. It's a serverless database service. No servers for you to manage. Very high levels of performance when it comes to querying the database, single digit millisecond performance at any scale. Get your response in your less than 10 milliseconds when we query the database. So a common database solution used for web applications, gaming. You have a large amount of data from various devices, Internet of Things, IoT devices, sensors, etc. We're generating data we need to store. Things like the on Amazon.com, for example, the shopping cart on Amazon.com. The shopping cart is a DynamoDB database, as well as other parts of Amazon.com, actually. And creating a DynamoDB database, very simple. If we were to do this manually, look for DynamoDB here. And we get started by just creating a table. And then part of the database design, you have to select a partition key. We'll do product ID here. Determines how the items are stored in the database. And that's all I need. We'll just do some basic, customize the settings, getting up different options for what type of performance do you need. And how are you going to pay for this? Since we're not really going to use this, we'll use on demand option here, where you only pay only for the database when you're actually using it. And then it's encryption to encrypt the database for additional security. And then that's enough. It's enough to create a database table. And that will oh, it's ready already. So let's see. Looks like it's ready. And then we could manually, through the interface, through the AWS console, we can add items. So let's go explore items. Of course, there's nothing in the database currently. We could create an item. And then this is the JSON view or JavaScript object notation form of the data. We can also just use the web form sort of view like this. Where I was going to have a product ID, and the value, well, that was set to a string. Should probably be a number type, no integer types value, but we'll just leave that as a string. And I can add multiple items here if I wanted to. We just edit the JSON here, put another product ID, product 200. And I could then modify the items if I wanted to edit the item. Let's go to the form view and add a new attribute. So the items we store in DynamoDB are made up of various attributes. And I can add new attributes as necessary. Go into string, number, so what's the value, type of data is going to be stored here. So if I did product name, we call it, see, widget number 1. And so on. So I could create additional attributes there. So there's my item, currently product ID, product name. So 2 attributes associated with that particular item. So the idea here is that sometimes you don't need relational databases. We have simple storage needs of the key value pair type of storage. We'll use databases like NoSQL databases such as DynamoDB here, and it gives us very high levels of performance. Then, what about migrating the database? Migrate database, database migration services available from AWS. So you can migrate databases from on-premises to AWS and simplify that whole process of moving over to the cloud. And what about networking and content delivery? That'll be our final topic here. We're going to get into the networking part of this. We'll look at things like VPCs and service called CloudFront and some other things here. So VPC. So of course, we need some sort of networking type of deployment. Some networking, the same as you would in an on-premises data center. You design your networks, and you have switches and routers and your cabling and subnets and all of that, and IP addressing, etc. Well, we still have that in AWS also. It starts with a VPC, Virtual Private Cloud, which is your area of the AWS Cloud infrastructure. VPCs are completely isolated by default. No traffic allowed in and out of a VPC by default. You are in complete control of that. And VPCs are defined by some IP address space. So you would need to select what sort of IP addressing, IP network address am I using? That IP address space associated with the VPC. And then you must create subnets also. You need at least one subnet. Means a further division of the IP address space to divide up the VPC. And then there are many resources which I would deploy, like an EC2 instance or the DynamoDB database we were looking at, etc., where you would select which VPC and which subnet inside of that VPC do I wish to deploy to. So you're seeing here, for example, if we look at it in context, we're in a region, so maybe we're in the Oregon region. Then in the Oregon region, you create a VPC, and you select some IP address range for that. And the VPC does span across and include every availability zone inside the region. So you could deploy to any of the four availability zones in Oregon. Once you created a VPC, deploy things like EC2 instances. And then you have to create a subnet. And a subnet is associated with a specific availability zone inside of a region. And subnets could either be public, meaning you've configured this subnet so that it has a connection to the internet. So traffic is allowed in and out to and from the internet. Or the subnet could be configured so that it's private, meaning there is no connection to the internet. Maybe I'm using this cloud deployment as a hybrid type model where I don't wish anything to be publicly available directly from AWS. I'm simply using the cloud as an extension of my on-premises data center. All traffic will come in through my corporate data center. Some resources hosted on premises in my data center, other resources hosted in the cloud. So we have traffic flowing through my data center, and some of my applications or databases, may be in a cloud environment. In that sort of deployment, that we'd have a private subnet. No need for it to be publicly available. That would simply create, unnecessary security risks. So if you look at the AWS console here, and let's go to the VPCs. And I'm in Oregon here at the moment. So in the web interface, you can see the regions. I could switch to different regions. It's just that easy. If I wanted to deploy resources in a different region, I just select it from the list and begin building some servers and storage, whatever I might need in a different region of the world. Right now, we're in Oregon. In the Oregon region, I have two VPCs. There they are. You can see they have address space associated with them, 10.0 and 10.1. And then inside each of those VPCs, subnets. Some subnets I have configured so they are connected to the internet. So those are labeled public, pub subnets like this. Others are private. They're not connected to the internet. And then when I deploy something like an EC2 instance, if we go back and look at that, I deploy an EC2 instance. One of the options that we saw previously was the network settings, which you can then edit. Which VPC do you want this EC2 instance? So this will be deployed in Oregon. You can select which VPC do you want. Then EC2 instances are placed in a specific subnet. So what subnet do you want for that VPC? This VPC has 4 subnets in it. I could place it in one of my public subnets or one of my private subnets as necessary. Other networking type services with AWS, Route 53. Route 53 is a DNS, the DNS service, translating names to IP addresses. You can host your DNS zones here if you want. You register new domain names with AWS. Use that for name resolution, either internally, meaning like just for your VPCs, just private sort of name resolution inside your VPC, or it could be public name resolution so that your customers can find your website. So we host that in Route 53 and use that to host your DNS zones and perform your name resolution for you. Route 53 is also what is known as a intelligent DNS service, meaning it has the ability to direct traffic to different destinations. So you know how we saw there's 34 regions around the world, right? Maybe you wish to direct different customers to different regions where you've deployed your application. So if I've deployed my application in a North America region, I've also deployed my application at my website, let's say in London, in the Europe region. DNS Route 53 could do something like if the DNS query from a user originates in North America, well, then I send them to the Oregon region. If a DNS query or my client customer traffic comes from Europe, I send them to the London region. Geolocation type of distribution of traffic, and that's what Route 53 is able to do, that sort of thing. So I can have different clients, different customers in different regions of the world and directed to a region that's closer to them, close to them in their part of the world. Other networking type resources, a direct connect. So remember the hybrid type cloud deployment, right? Where I have my on-premises data center. I want to connect that to the cloud environment like AWS. I need some sort of connection here in the middle. I need something to connect my on-premises data center to the cloud. Direct Connect is one of those options. Direct Connect is a private, dedicated networking connection from your on-premises location to AWS. Private dedicated connection means it's dedicated just to you. It's not using, none of your traffic is going across like the public internet. And the other option here, Direct Connect or for the same sort of hybrid deployment, you could have a VPN, virtual private network, but of course, that's using the internet as its backbone. Your traffic then would be traversing the internet if you were using the VPN, which might not be desirable from a security standpoint. And you don't get a guaranteed level of performance either. Your performance with the VPN would depend upon internet congestion. And Direct Connect, of course, gets around that, eliminates that issue because it's a dedicated private connection dedicated to you. Then earlier, remember, we were looking at the global infrastructure on AWS, and we had, in addition to our 34 regions, 600 plus additional points of presence. The edge locations, where AWS is also deployed uh, a presence, right, in hundreds of additional locations around the world. And that edge location type of architecture is utilized for the content delivery network caching. Going to cache content in multiple places around the world, hundreds of locations. And the service that provides that is CloudFront. CloudFront is our CDN content delivery network. Primary purpose there is to host or cache, store content in various places around the world so that it's closer to your customers. The customers get a better experience, lower latency by having your content cached in a location that's closer to them. So if you were to only deploy to a single region, you're only deployed to the Oregon region instead of customers around the world, whether they're in Asia or Europe or South America, setting setting for them to having to go to all the way to the Oregon region to retrieve the content, which means a lot of internet hops and a lot of long haul across the internet from Asia to the Oregon region. We can host the content that's in a location that's closer to the user. Content could be cached in a location that's in Asia, closer to where the actual customer is consuming the content. Like this. So this example of actually hosting my content, maybe this is a video. It's in the Sao Paulo region in South America. And if I had a customer in Japan, well, that's a long haul of traffic across the internet for them to get that video. Performance would suffer, increased latency, increased chance for packet loss and the video not playing correctly. Whereas if I take advantage of CloudFront and the edge locations, I can have that video cached in a location that's in Japan with the customer, providing a much better experience for them, much closer to them to access the content. Now, as we conclude this presentation, some of the key takeaways in a broad selection of services, 200 plus services available from AWS, and those are being constantly refined, and new services being introduced. Pay on demand, pay only for the services you use, pay as you go type of strategy with the billing from AWS. So that will conclude the presentation. Thank you everyone for attending. Thank you for taking the time and listening.